Hello everyone, I hope you all are doing great. Today I will be studying the chapter Electricity. This is from class 10th physics, first chapter. So without any further delay, let's start. So what is electricity? In a very simple word, the flow of electron is known as electricity. Now what is electron? In previous classes we have studied an atom contains three things, that is proton, neutron and electrons. The proton and neutron consist the nucleus of the atom, and there are electrons which are orbiting the nucleus, and electrons have negative charges. So now when these electrons move in a substance, then it constitutes electric current. That's why we call the flow of electrons is known as electricity, right? Or you can say flow of charges. There can be two types of charges. One is positive charge and second is negative charge. One thing to note is that electrons are the negative charge. So like charges attract each other and unlike charges repel each other. What do you mean by this? It means that positive and positive charge, two positive charge, one positive charge, another positive charge, if you bring them together, they will repel each other. And in the same way, when you bring two negative charges together, they will again repel. But if you bring two unlike charges, that is one positive charge and one negative charge, if you bring them together, they will attract. Many students get confused between this. How to remember? Ladka ladka, dushman. Ladka ladki, attract. Just remember like that, okay? A boy will attract a girl, that is opposite, right? A boy will never attract another boy, a girl won't attract another girl, right? So positive and positive will not attract each other, negative and negative will not attract each other, but a positive and a negative will always attract each other. Remember like this, okay? We denote charge with the alphabet capital Q. So whenever you say charge, whenever you see something written as Q, then it means charge, and the unit of charge is coulomb. For example, the SI unit of speed is meter per second. In the same way, the unit of charge, electric charge, is coulomb, and we denote it with capital C. But don't get confused between Q and C. Q is a denotion. We denote charge with Q, right? And C is the unit of charge. For example, we denote speed with S, right? And the unit of speed is meter per second. In the same way, we denote charge with Q, and the unit of charge is coulomb. Correct. Now comes conductors and insulators. From the very beginning, from class 7, 8, 9, we have studied conductors and insulators. Conductors are those materials from which electricity flows, and insulators are those materials which does not allow the flow of electricity. But here we have a question: why conductors allow the flow of electricity and insulators does not allow the flow of electricity? As I have told you, electricity will flow. Electricity is the flow of electrons. So conductors have excess of free electrons. One thing to keep in mind: excess electrons, excess free electrons. Both conductors and insulators, they both have electrons. But the difference between conductor and insulator is that conductors have free excess electrons. It means that the electrons in the conductors can move freely. So when electrons can move freely, it produces electricity. That's why electricity can flow through conductors but not insulators, because in insulators there are no free electrons to produce electricity. But that's the main difference between conductor and insulator. So now we are going to start electric potential. So what do you mean by electric potential? Let's imagine there is a charge Q, right? Imagine there is a charge here, there is a charge, okay, and you want to bring this charge from this point to this point, okay. Let's imagine this point is A and this point is B. So you want to bring this charge from point A to point B, that is here. So to bring this charge from point A to point B, you have to apply some force, right, and bring this charge from this point to this point, right. So when you apply some force and brought this charge from point A to point B with some distance, so you have covered some distance and you have applied some force. You remember work done? What was the formula of work done? Work done was work done equals to force into distance traveled. So to bring this charge from point A to point B, you have to do some work on this point A. Here we don't know this point A lies where, we don't know. So we will consider that the point A is in infinity. So electric potential is the amount of work done to bring a charge from infinity to a point A. Got it? Here remember the word, a unit positive charge. A unit positive charge means 1 coulomb of charge. It means that to bring it means the amount of work done you have to do on a 1 coulomb charge to bring that charge from infinity to a point A is known as potential, electric potential. Now what is potential difference? Let's imagine here's a water bottle and here's another water bottle, and this water bottle is fully filled and this water bottle is half filled. So if you connect both the water bottles with a pipe, then where the water will flow? Water will flow from the bottle which has more water to the bottle which has less water, right? Or a river, how does it flow? It flows from higher region to a lower region, right? The same thing is with the electricity, electric charge or electricity, whatever you want to say. So electric charge flows from an area of higher potential to a lower potential. What is potential? I have told you, potential means the electric potential, or you can say the concentration of electrons. Suppose there are 2 points, point A and point B. If point A has more electrons and point B has less electrons, where the electrons will flow? Electrons will flow from point A to point B, from the area which has more electrons to the area which has less electrons. Got it? So this difference in the electrons is known as potential difference. Okay, so there is a point A and there is a point B. Both has different types of potential. What is potential? I have told you earlier, it is the amount of work done to bring a unit positive charge to that point, right? So to bring a unit positive charge from infinity to a point here is different from the amount of work done to bring that very same 1 unit of charge from infinity to another point B. So the potential of this point A and potential of this point both are different, right? So and this difference is known as potential difference. And always remember, current flows, electricity flows from a region of higher potential to a region of lower potential. Okay, you can calculate potential difference with the formula PD, that is potential difference equals to work done by amount of charge carried. So if you want the notes or the proper definitions of electric potential, potential difference, current and other things, you can just type them in the comment section below, or you can also visit my Instagram. The link is given in the description below, and just message me. I will send you the notes absolutely for free. Don't worry, there is no charge. You can just DM me, okay? And also you can email me, that is snappescholars2000@gmail.com. So let's continue. We denote potential difference with the alphabet V. So V equals to W by charge. Charge means what? Q. So V equals to W by Q. Alright. Now in practical life, we use, how do we calculate the potential difference? I have told you na कि potential difference calculate कर लिया, ऐसे हो गया. This is a difference, like potential difference is a difference in the potential of 2 points. Okay, this is theory वाला thing, right? But in real life, how do you measure potential difference? कैसे measure करेंगे? So to measure the potential difference, we use an instrument called voltmeter. How? Where is the name came voltmeter? Potential difference means we denote it with V. V for voltage. Voltage and potential difference is same thing. Don't get confused. Okay. So we calculate potential difference. So we calculate the voltage with voltmeter. We calculate speed with speedometer. And the same way we calculate potential difference, it is voltage with voltmeter. Don't ever forget this. Correct. In exam, very commonly there is a question which is asked. How do you connect voltmeter in an electric circuit? So your answer must be always parallel. So now, what is parallel and what is series, you might not know. I'll talk about this in the next incoming videos. Till then, just remember, voltmeter is always connected in parallel in a circuit to reduce resistance. You might know what resistance is also now. I'll be telling you in the coming video. But for now, just remember, resistance means resist, anything which resists. रास्ते में जा रहे हैं हम लोग. So to slow down our speed, what we use? Speed breaker, right? In the same way, when current is flowing, to slow down the flow of electricity, we use resistance. For now, just remember this much. Okay. So voltmeter is always connected in a parallel in a circuit to decrease the resistance. Okay. So now it's electric current. I have told you about the charge, right? And the flow of charge causes electricity or electric current. But there's a formula to calculate the amount of electricity. That is, for example, there is a wire and this is the positive terminal and this is a negative terminal. Remember, always the charge flows from higher concentration to a lower concentration, right? And here, in case of electricity, charge is the electron, right? So electron will be more on negative terminal because the charge of electron is negative. It's more the electron, more is a negative charge, and less electron, more will be the positive charge. So electron will be flowing from negative terminal to the positive terminal, and electricity will flow from positive terminal to negative terminal. Remember, current flows in the opposite direction to the flow of electron, that is from positive terminal to negative terminal. Electrons flow from negative to positive and electricity flows from positive to negative. Okay, don't get confused. Coming back to the point, imagine there is some charge Q. To reach this, for this charge to flow from this point to this point, it needs some time. Let's imagine that time to be T. Okay, so here electricity, that is I or electric current, will be equals to amount of charge flowing, that is Q, divided by the time taken, that is how much time it has taken to flow from this point to this point.